Our last speaker for this session is Dr. Simone Stumpf. Dr. Stumpf is a reader in Responsible and Interactive AI in the School of Computing Science at the University of Glasgow. She has a long-standing research focus on user interactions with machine learning systems. Her research includes self-management systems for people living with long-term health conditions, and developing teachable object recognizers for people who are blind or low vision, and investigating AI fairness. Today, her talk will be focusing on interpretability, fairness, and controllability in AI. The floor is yours.
Hello. So thank you for inviting me. I'm not a data scientist or machine learning expert. I'm a human-computer interaction person. So one feature of that is that we will not see any formulas in this talk. So today I'll be talking about my work in interpretability, controllability, and fairness, and also how that feeds into responsible AI. So when we're talking about responsible AI, I want to delve into three aspects. So one is interpretability, which is the ability of a user to understand the behavior of an AI system, how it actually works, how it makes decisions. Controllability, that means the ability of a user to control how the AI behaves. So it's not necessarily just in the hands of a data scientist or machine learning expert that trains a model. And then finally, fairness, which is the ability of the AI system to make fair decisions. So first delving into interpretability, this field has really sort of taken off following the DARPA XAI call back in 2016. And you probably are familiar with this vision that it sort of said these machine learning models are black boxes, and therefore what we want to do is move from what was today in 2016 to the XAI model, where we explain to the user how decisions get made, or how a machine learning system behaves, and so they can understand why or why not certain conclusions were reached. They can actually determine when they fail, and so on, right? So lots of work has been going on in this space. I won't bore you with the details. Most of you are already familiar with it, and in fact, a few of these approaches have been mentioned in the previous talks. So where it's becoming new is controllability. So that's the ability of a user to change the behavior of the AI system. And that really depends on something that is called calibrated or appropriate trust. You have to think about whether the AI system is actually making the right decisions, right? Can you spot mistakes? And based on that, you then hopefully can make appropriate changes that are integrated back into this machine learning system, either as part of the training data, or changing the machine learning process, or changing the model. Right. So my work in this area has revolved around what we call explanatory debugging for interactive machine learning. Interactive machine learning works on a tight coupled cycle between a system here and a user over there. And the idea is that we explain what the system is doing in terms of its decision making, and we allow the user to feedback and control, and that feedback is integrated back into the model. So hopefully what we end up with is improved behavior by the machine learning model, and also improved mental model or satisfaction of the user with the system. So we've been publishing on that since 2009. The latest sort of work was in 2015. So what we've been doing as part of that is developing a lot of user interfaces and also approaches of how to integrate user feedback back into decision making. I won't go through that, but if you're interested, you can read up in our IUI paper that was published in 2015. Now, fast forward to fairness. And fairness is a human value. There is, it might be captured through some mathematical notions, but at the end of the day, what is considered fair is mainly up to people, right? And so what we need, if we wanted to determine whether an AI system is making fair decisions, is that we need interpretability to understand whether something is fair or not, right? So that is where XAI comes in to fairness. There have been more recently some tools to find and mitigate bias or fairness issues. IBM Fairness 360, for example, is one of those tools. But one of the problems is that there's lots of metrics about to measure fairness. The latest count is over 21, right? And so you always come up with the problem, well, which fairness metric do you choose, right? Which one do you optimize for? And that is actually really contentious and depends on the context of where you're making that decision. Another problem is that you probably don't want to give data scientists the sole power of determining what is fair, right? And so one of the ways that I've been approaching this more recently is to bring the human back into the loop in evaluating the fairness and then actually integrating the user feedback on fairness back into the model. So in my talk, for the rest of the talk, I just wanted to give that as an example. My most recent work with Fujitsu Limited, which was published quite recently in the Transactions on Interactive Intelligent Systems, where we took user feedback and developed that into AI fairness. So we leveraged work from explanatory debugging in terms of finding and fixing fairness bugs that do not meet users' expectations. We actually applied that to a loan application domain because we wanted to test it on a large number of users, and the loan application domain is very easy to understand, but we think that our work also has implications for other domains. We used an anonymized data set from a partner bank just to say this data set was fair, right? We recruited 388 participants through Prolific, which is a crowdsourcing platform. They didn't have any technical or domain expertise to do with loan applications. We developed a logistic regression model, which is a common model that is used in the loan application domain. It's not very accurate, 61% accurate, but more importantly, training on the data set, we made it, well, it turned out to be unfair. So it failed the disparate impact metric, which is quite often used to measure fairness. And anything under 0.8 is definitely unfair. And it did so in respect to the nationality attribute. So in the database, in the data set, we have citizen foreigner. So it rejected far more loans for foreigners than citizens. Okay, and we allowed them to give feedback, and what we did afterwards was a little offline experiment where we used the average weight value for each attribute suggested by the participants on the application and recalculated the model. So this is the interface that we developed. It sort of bears a family resemblance to the interfaces that we developed previously as part of the explanatory debugging approach, but it gives the user some information about how many, which of these loan applications is predicted to be accepted or rejected. They can sort on various things. We give them a confidence level of the system, of how confident it is that this should be accepted or rejected. We also give them some information about the attribute and the weights on the attribute visually, and then we also allow them to compare applications against each other. Right? Now, one of the important things is that they were able to give two kind of sets of feedback. Either they marked up an application as fair or unfair, or they could suggest changes and then drag the weight of individual attributes or features up and down. Okay, so far so good. So that's what we did. So let's go on to the results. So participants found this UI really easy to use and useful in using and figuring out fairness. They use the UI to find problematic decisions through sorting, filtering, unpredicted decision, confidence comparison. So they really went to town using the AI. And what that led to is that 20% of assessed decisions were judged unfair, and they mostly honed in on nationality, which is what we wanted. And then when looking at nationality, unfair was applied to the majority of accepted citizens. So, which is kind of a little bit weird because we would expect them to actually mark most of the rejected foreigners as unfair, but that is actually not what happened. 230 participants made weight changes to 3.7 on applications on average, and these suggested weight changes actually improved the disparate impact. So suddenly it went from failing on disparate impact to not failing, which is exactly what we were hoping for. However, a majority, well, 50% of participants increased the disparate impact to 0.91, which is very good. Unfortunately, there were also some participants who decreased the disparate impact, so they made the model actually more unfair than it already was. And so there is plenty of work to do around this area of integrating user feedback. So just to wrap up, in takeaways, so human in the loop fairness tools can work. We hopefully prove that through our work, and we are really keen to extend to other domains and other situations. We still have lots of work to do on interpretability and how to support users to find fairness bugs. Work around user interfaces, how to communicate with stakeholders, domain experts, and so on. We also need to do some research on how to integrate user feedback into these models. If you're using logistic regression, that is fairly benign, I would say, but how do you integrate user feedback of that sort into deep learning models? That's still quite an open question. But we currently have a project running called the EFI project, which is trying to tackle both of these areas. And then finally, we need to figure out how to put the human back in responsible AI development processes. So if you think about this sort of development process, where does the human come back in to give you that sort of feedback about the fairness? You know, is it at the data gathering stage, the building model stage, where do we need to bring them back in, right? And on that, I conclude my talk, and hopefully, if you have any questions, have to answer them now, or I'll also be around during the break.
Thank you. We have time for maybe one or two questions, and then I'll have to make a short announcement after that. To start off, I would like to ask one myself. Fairness and ethics, I think, are understandable concepts, but interpretability for me is a bit harder to grasp. How would you ensure interpretability for a research project as a everyday researcher?
So interpretability is an interesting concept because it's not the same to me as explainability. So explainability is you kind of extract something from a model, and hopefully that will sort of work to make the model more understandable. Interpretability is really something on the behalf of a user. So it means that the targeted user, has a better understanding of how the model works and makes decisions. So it's all internally, and it will depend on the user group that you're targeting. So, interpretability is not the same if you're talking to somebody, a lay person on the street, versus perhaps to, a medical expert like a clinician. So you have to really think about targeting this user mental model and building on the back of that, and that is really important.
Okay, thank you very much. There seems to be one more question there, and then I think that will be all the time we have.
Thank you very much for the question. Okay, so I wanted to know about the loop that you have created when you explain the machine to the user, and then you get the feedback from the user, and the user then control the workflow. So I just wonder whether the user will be the expert in the domain of the AI, or if they are not, so what sort of feedback they will have to do into the machine, and what level of control they will have on the model.
Okay, so sorry, going back. Here we go. So most of our systems were developed for lay users. So and in that domain, which was taught in newsgroups, it was just foldering essentially, or classification. We've also done some work with different stakeholders like domain experts or data scientists, and the complexity of what you can show obviously increases if you have different kind of user groups, right, with a sort of different abilities, right? The thing is that this interface for lay users, for example, was very simple. We gave various explanations in various forms. So there's some global explanations, some local explanations as well. And we allow them to interactively change or give feedback through these explanations. So for example, you have a bar graph of the important features in making the decisions, and the user was able to grab these bar charts and move them about, so they could again signify or change the shape of the features. And again, it works, right? So you just have to be careful about crafting the user interface and also the feedback mechanism to be appropriate for the targeted user group or stakeholder.
Okay, thank you once again. I think that's will be all the time we have, and one more round of applause for Dr. Stumpf and all the speakers. Now we'll have a half an hour coffee and tea break, and we'll resume at 12 with an excellent and fascinating talk from Dr. Brendan Tracy, who's working on some crazy stuff with tokamaks. We also have a poster session, and we will be handing out a little prize at the end of the day for the best poster. So with that said, everyone enjoy the rest of the conference.